Welcome everyone. My name is Jamil Gavada. In this video, we are going to be conducting or creating a Naïve-based machine learning model. However, before we do that, I would like to explore the data set that we are going to be using for this machine learning model. So we are going to be using a social network ad data set. The data set contains the details of users on a social networking site to find whether a user buys a product by clicking the ad on the site based on their salary, age, and gender. So here's the our data set. Of course, we have the user ID, we got the gender, male and female, and we have age, we got this estimated salary, and we got the purchase column. If it's a 0, that means the customer didn't buy. If it's a 1, the customer did buy the product. So we have 3 independent variables, or in machine learning, we call the independent variables, we call them features. And of course, we got the dependent variable. And in machine learning, we can use dependent variable or we can use target vector. So our 3 independent variable or features for this model are going to be gender, age, and salary. And our dependent variable is going to be purchase. So that's the model. Okay, so now after examining the data set, it is time to look at the code, at the machine learning code. So this is going to be a Naïve-based machine learning model. And the first thing we always do when creating a machine learning model is to import the libraries that we are going to be using for the machine learning model. And this block of code is going to do that for us. We are going to be importing NumPy, Matplotlib, Pandas, and sklearn. So let's run this code. Now, after importing the libraries that we are going to be using for the machine learning model, now it's time to import the data set that we are going to be using for this machine learning model. So we are going to be importing the social network ad CSV file to the Python environment using this block of code. So we run it. Excellent. Now, remember that this, the gender independent variable or column here is actually a character variable. So we need to transform this character variable to a numeric variable. So we need to do that. So this block of code is going to be using the label encoder to transform the character variable to a numeric variable. So let's run this block of code. Excellent. Now we need to actually split our data set into 80% training and 20% testing. And this is exactly what this block of code is going to do for us. So let's run it. Okay, perfect. So now, after splitting our data set, after transforming the character variable to numeric variable, and importing the data set into the Python environment, and importing the libraries that we're going to be using, now it's time to do a standard scaler. We need to transform our data set into a standard scale. So this is exactly what this block of code is going to do for us. It's going to transform our data set into a standard scale. Okay, so let's do that. All right, perfect. Now we can create a machine learning model, the Naïve-based machine learning model. And this is exactly what this line of code is going to do for us. So let's run this block of code, and it has created a machine learning model. Now let's do some prediction. So here we're going to take the X test of a data set, and we're going to make predictions. Perfect. And now let's print those predictions. As you can see, we got 0, 0. Remember, 0, that means that the user or customer didn't buy the product. And 1 means that they did buy the product. Now, let's look at the actual values. What actually happened? Let's see what happened. As you can see, these are the actual values here. These are the actual values. These are the predicted values. And as you can see, it seems like here are pretty much the same. It seems like the model was highly accurate at predicting whether the client or the user or the customer actually bought or didn't buy the product. Okay, so now let's look at the accuracy of our model. Here's this line of this block of code is gonna calculate the accuracy of the model. Now let's print the accuracy of the model. And the model has an accuracy level of 92.5 or 92.5% or 0.925. This means that this model is highly accurate. So again, this is the Naïve-based machine learning model. And I hope that this lesson has proven useful to you. And I wish you the best as you continue in your studies.